you would know, the topic is talking about secure pipelines. Um, when we talk about security in general and AppSec in particular, there are various ways to do it. So there are often times that we would, go for automated solutions to automate some of the recurring tasks, and there are also ways when we are trying to, manually review and figure out where could be the loopholes, where could be the design go wrongs, and then maybe do threat modeling and other things and figure out where it is and put the necessary controls over there. So there are various ways of doing it. And one of the interesting ways and one of the very, very efficient ways when dealing with a huge application or maybe a large amount of bugs that may creep up, or a bigger code base, is to tackle these recurring security issues that you might find, and also get immediate feedback as a developer. That brings a lot of control to the hands of the developer, and that's what we aim to achieve, at least for most of the projects that we do. And that's the idea. And hence the secure pipeline series is what we introduce, is because there's a lot of cool work that a lot of the folks are doing in this particular area, and we want to listen, hear about it, talk about it, and see what are the challenges that we face in a real project situation, and how to go about solving some of those challenges in a very efficient way when we are trying to set up and use and maintain secure pipelines. So over to you, Swati. If you could introduce our speaker for the day.
So we have today with us Ramakrishnan. Ramakrishnan is a DevSecOps, and he's also playing the role of a QA in ThoughtWorks. He has 8+ years of industry experience, and he's very passionate about building secure pipelines and also about automated security tools. So today we are going to talk about why do we need to run these security tools in our pipeline? Why do we need to have security checks in the pipeline? We're also going to talk about secret scanners, dependency checker, SAST, DAST, and a lot of various other things. So I'll hand over to Ramakrishnan now.
Thanks, sir. We start sharing my screen. Is my screen visible?
Yes.
Yes, Shanti, yes.
Okay. So the topic I wanted to talk today was how to inject security into pipelines. So we always, I think the most of the crowd, everyone here will be know, right? Security is always important, but there will be always the questions on where I need to get started, on how much security is enough, or whether I'm using the right set of tools. There will be a lot of questions will come to our mind, right? This particular talk is mostly focused on how to approach security in an automated tools fashion. Um, I'll, uh, we'll try to cover what are the practices we can automate, and also how we can do the automate in a right way, and also what set of tools, and also share my experience on the automation I have done so far, and what are the learnings I had, and what are the places I have failed, and what improvements I helped me to move things forward. So we can imagine this is a typical common pipeline, right? We'll be starting with downloading the dependency, building the application, and running our unit tests, packaging our application, and then maybe deploying it, and then running our some of our end-to-end tests. This will be our typical common pipeline will look like, right? We'll be seeing how we can add additional tools to it, and how we can efficiently use it with the same similar kind of pipeline. So, okay. So the first question I wanted to answer was why I need to use security tools in the pipeline, right? Because there will be in most of the organizations or the clients we work with, there will be a dedicated security team who takes care of reviewing the code, or doing all the security related activities. Uh, uh, why we need to have a security tools in the pipeline is those activities will come very at the later stage. Again, the same thing. We need to have a faster feedback, similar to the unit tests or the intern tests. To get a quicker feedback on security issues, we need to have security tools in the pipeline. That's the primary reason of it. And what I'm going to get benefit out of it also, will be able to find security issues earlier in the pipeline stages rather than at the end or at the penetration testing stages. So to think about implementing a secure pipeline, we will try to understand what is the composition of an application is. For example, if you are developing any application or services, what will be the typical composition of a software application? Those could be first initially starts with an application code and a set of application dependencies, and then all those will be packaged and together it will be running in an operating system or a container image or a VM or in a some runtime, either in a cloud provider runtime or those things, right? And then we'll have some infrastructure as well. Either infrastructure, we'll use infrastructure as a code or the doing those configurations manually. This will be the typical composition of a software application, right? So we'll start thinking about how to implement security for each of those individual components. First, we'll start with the application code. Let's think about what are the practices we can apply for a application code. The first common practice would be uh, application code can often refer to a secret. For example, the secret can be any AP credentials or the default key used to encryption, those kind of things. That could also be tied to a source code, right? It may even refer an environmental label. Sometimes those environmental labels will be either bundled in your infrastructure code or all those, right? So secret scanner is a plays a critical role here. So we need to identify secrets from accidentally being checked into the repository. The primary reason for it is if your source code is got leaked, your secrets even will get also leaked to everyone. Or if you're sharing a read-only access to your one of your team member who is going to join, you'll be accidentally sharing your production secrets as well. So to avoid those kind of issues, we should have some secret scanner tool. What those secret scanner tools will be doing is it will be either will be doing a pattern matching like AWS key ID, those kind of variables are present or based on the some regex patterns, or there are some tools which works based on entropy, like if it finds like entropy like set of character which totally differs is what entropy is, right? So whether if it is entropy of a particular string is higher, it will detect and notify it as this could be a string, password string or an key token, all those. So to avoid secrets from being checked into a repository, there are two ways to approach it. And the first one is preventive, like we can prevent the secrets from even being checked into the repository at the first place itself. Like we'll block it from in the dev machine itself. To achieve it, there are two options we have as of now. One is the Bitbucket plugin. Bitbucket has a security plugin to block secrets. I think most of the other source code repositories as of now don't have those options, but Bitbucket have those options. Like whenever you make a commit and push it, it will block you if it finds any secret patterns. The one other our own ThoughtWorks tool was the Talisman. This tool again, it also works based on entropy. It can detect and block the secrets. Unlike the Bitbucket plugin, this tool will run your the developer's own laptops or the desktop environments, where all the people who are involved in the development process have to install this particular tool. Uh, the next approach will be proactive, like you can detect if the ZKS has been accidentally pushed in the pipeline. Like you can set up this either the Talisman or Truffle tool in the pipeline to detect secrets so that you will get notified. Then you can follow the incident response plan for your team. Like a secret has been accidentally checked in, what I have to do. Those incident response actions you can take further. But this secret scanner is most primarily on detecting those kind of uh, no one will be intentionally checking it. This could be in accidental check-ins, right? So to detect all those accidental mistakes, we can either follow these two approaches. Proactive approach we can use in a place where we collaborate with a lot of other folks where we cannot control to have everyone to have a talisman installed on their machine. Okay, I'll move to next. Okay, and next one is doing a static analysis on your code. In the static analysis part, there are two categories. There is a linting as well, like for code quality, but that is totally separate from the security part of it. For code best practices, lot of why I'm talking about linting is lot of tools here also does linting part as well. So when you integrate, you will get those other additional benefits as well, or the maybe pain points to write code in a such a way as well. Just calling it out. So the static code analysis is it will try to identify bug patterns in your code and try to raise it as a vulnerabilities. So since there are two approaches to do the tools takes to do is one is either to do a pattern based matching, a regex kind of matching to identify the vulnerabilities. The other one could be identifying based on the compiled source codes. It can, for example, it can try to identify, for example, if an input is passed from multiple classes in a Java code, it can identify those and trace back and identify whether any injection attack is possible or not. So there are both kind of tools are also available. So I have given the two set of tools here. The left section was mostly on the open source tools, and the right on the mostly on the paid tools. We'll see about how we can choose a tool. For static analysis, the primary thing would be whether the tool we are choosing, whether it supports our the tech stack what we are using is the first primary checkpoint. So how to choose any static analysis tool will be static analysis tools are very known to be providing false positive things. Like it may detect that there is an SQL injection possible in a particular line of code, but if you check, you might be actually using a prepare statement, and it will be detecting that SQL injection possibility. So even with the paid tools, there is always a pain point. So the thing we need to consider here is whether the tool, whether it supports option to exclude those specific finding from the list. Like if it identifies any false positive, whether as a user I may have an option to mark it as false positive. And the next thing would be the list of rules. There are a lot of tools available. So to check for this particular tech stack for my particular language, what are the number of rules available? The more number of rules, it is always the better. It can identify more number of security issues. And also there are some tools which can also provide you recommendations as well, like how you can fix this particular kind of vulnerability as well, or even some kind of example snippets where the issue occurred and how the fix can be implemented. And also there are tools which are providing ID integrations as well. You can integrate it in your ID. It can give feedback during your while you code as well, rather than having it in the pipeline. Those options are also available. And also one more thing we need to check on this as well is whether it covers all the top 10 vulnerabilities and all the top common vulnerability enumerations in the analysis part of it. And I think again the most primary point will be whether it supports your tech stack or not. Even the paid tools, if you take, won't support all the tech stack, wide variety of tech stacks. So you just need to be careful on whether it supports my particular language, what I'm using to code. So this is about application code. In the application code, we need to think about two things, like the static analysis and the secret scanner. Uh, Next thing is on application dependencies. Like for to develop any application, right? We may require to use other third-party libraries because we don't want to reinvent the wheel, right? If it is integrating with the database, we'll be using a JDBC connector, like those to avoid those reinvention, right? So it will be definitely depending on some application dependencies. So there could be possibility on vulnerabilities in those dependencies as well, right? So that's where this dependencies checker comes in place. This application dependency checkers will check for whether is there any known vulnerabilities in the application library I'm using. For example, I may be using hundreds of libraries. Even the hundreds of libraries will have a own set of 100 transitive dependencies. Like those libraries could be vulnerable. So this dependency checker will help you to identify those whether is there any vulnerability in those codes and that got fixed, and whether is there an option to upgrade, and what is the version to upgrade. Those kind of insights will be given by those dependency checker. So the some common dependency checkers are the dependency check or the aqua or the from sneak or safety or the Nancy for Go, and also the interesting one will be the dependabot. Like dependabot, I think we had earlier had a session on separately on dependabot, but dependabot is free for open source and it is from GitHub, and it can create pull request if it finds any libraries out of date, plus any library has a security vulnerability and which we need to upgrade. So one primary thing to evaluate while choosing the dependency checker tool will be whether what are the list of data sources this particular tool refers. Like these are the common, very basic set of list of data sources I have listed. Like this, I think this should be mandatory whether the tool should be referring. Like the NVIDIA database or NPMs for the Node.js projects, the OSS index from the Sonotype, or the VulnDB or Ruby advisories, all those advisories databases. Whether how many number of data sources the tool uses is the key factor to choose any dependency checker. Um, Based on my experience, the for I've used mostly on the tool which supports natively for that particular tech stack. For example, for NPM for Node.js projects, I'll prefer to use the NPM audit itself, because that is very native to the NPM ecosystem and it can identify all the NPM related Node.js package related vulnerabilities. For Ruby, the bundler itself has a bundler audit plugin. And for all other things, OS dependency checker also has a very good opportunities. And also, even in the dependency checker, there are also possibilities of false positives. So also just make sure that whether the tool has an option to exclude any particular vulnerabilities if it is a false positive. And one other thing on the vulnerabilities could be the license checking part. Like all the libraries, right? It will come with one separate set of licenses. Like each licenses are not same, right? Uh, so we need to think about those license part as well while using those libraries, integrating those libraries into our application. So this license checkers, what it will do is it will verify whether it is your application using only approved licenses by you. I'll show a demo on the license checker part for all the tools as well. There are majorly three categories: whether I'm using a permissive license or a public use license or non-permissive licenses. The permissive licenses, we don't need to care much about it. Like BSD and MIT and Apache, we can use it for commercial purpose and we can redistribute it. There is no much restrictions to that licenses. The public use licenses will have some restrictions, like whether if we are customizing those source code, we need to publicly disclose those source codes, and we need to include the OSS disclosures or the attributions file. All those will come into picture. Non-permissive licenses are a bit more stricter in a way. We need to be a bit more careful on reading those license terms and checking whether I need to use it or not. So in the license checker space, there are quite a few tools available, or I am aware of only very less tools. Like the first one is the Pivotal's license finder, and the other ones are FOSA and white source. Those are the automated tools which can help you to do it. The Pivotal license finder is the one which is for open source, and FOSA and white source are for free for open source projects, but we need to pay when we want to use it in commercial applications. The Pivotal license finder, I mostly tried with multiple textures, and it works very well, quite well. And also it has pipeline native as well, so we can use this. So next is software composition analysis. This is a combination of both the license checker and the vulnerabilities checking part, but in a more structured way. Like this software composition analysis tools, what it does, what it gives benefits for us is these four things. Like if a new vulnerability is disclosed, these tools can identify and send a notification to you. Whether if you're irrespective of whether your pipeline is running and checking whether any dependencies or not, that you can ignore that part, the whole part itself. And if a library is marked as end of life, it can detect and send a notification to you as well. And if any library is going a major version out of date, or again the end of life, all those you can monitor those things. And also this software composition analysis, right, this will be typically done for like a, if it is running if an organization is having a lot of applications, or if a particular application is having a lot of microservices, these applications will be running monitoring all those applications as a centralized management system. And also, if a development for any particular project is stopped, right, this software composition analysis tool will be keep on monitoring your application dependencies and will be sending alerts for you. The one open source one was the OS dependency track. Fossa and White Source also has offerings for all those same software composition analysis as well. As of now, in the open source world, the only good tool for the software composition analysis is dependency track. Yeah, this is about the application dependencies. In the application dependencies, we need to worry about whether my library has vulnerabilities, or the license what I use have any distribution restrictions, whether it have any legal implications when I use it in our application development. I'll pause for questions.
Are there any questions until now? Please feel free to call out.
I have a question. Can you reiterate on why a license checker is important?
Okay. Okay. Basically, the in open source world, right? All the licenses are not same. If it is freely available, all the freely available software will come with certain restrictions. For example, if you take an example of a GPL license, for a GPL, okay, I'll take example of LGPL license. If you are using any library with a LGPL license, you have to release your application in a LGPL license. That is mandatory. Like if you use any LGPL license in your application code, you have to release your application code as a LGPL license, and you have to open source the whole code. That is the restriction we have. So if the library is even available in free on the internet, we need to think about the legal and license implications as well.
Great, thank you.
Okay. These are the tools which does it in an automated fashion. Like these license checking, we can do it manually. Like we can go each individual library and check what is the license. But I think that is a time consuming, and also if it take into account of transitive dependencies, right? I think manual is impossible nowadays. When we see the list of dependencies, we will have it in our application. So these automated tools will help you in identifying those. What are the non-permissive licenses I have it in my application dependency.
And what is the tool suggested by you, Ramki, for that?
This is in the license checker space is I think there are lot of quite good tools available as of now. The only open source tool which works for most of the tech stacks will be Pivotal License Finder. I'll share how to set it up in the pipelines while I'm coming to the pipeline part.
Sure. Cool.
And if you want some paid offering, the Fossa and White Source does a good job for you. Okay, I'll move to next. So we have seen like how to scan our application code and the differences with it. Now we done with the application part of it. This application will be run in some operating system, or some in a cloud environment, or some in a serverless space, right? So how we can think about running and doing checks for those. Typically, will be in nowadays we are moved away from deploying applications in VM side. We are currently running either in a serverless space or in a container space. So to do the container scanning, there are quite a few set of tools available. Why we need to do container scanning? Again, each operating system is set of libraries and packages, right? It depends on separate set of open source packages and libraries. So again, we need to look into whether those libraries and packages have any known vulnerabilities or not. For example, most probably all the runtimes will be depending on a basic C library, libc or gcc C library. Whether those libraries have any vulnerabilities, or all the operating system will have basic kernels in it. whether those kernels have any vulnerabilities in it. Those are the just some example packages. If you take operating system, there is always a huge set of packages. These tools will be helping into analyzing whether those packages have any known vulnerabilities in it. How it does, again, the same set of data sources we talked about for the application dependencies, right? For this as well, there are separate set of data sources, either from a NVD data source, or each OS flavor will have their own data source. For Alpine, there is a separate data source. For Debian, there is a separate data source. So this container scanning tools will help you to identify the list of packages you are using in your container and scan against those known vulnerabilities. The set of tools are Trivi, Anchor, Aqua, and Claire, and there are a lot of paid offerings as well. I have not explored much tools on container space. I was most satisfied with the Trivi results. Trivi is a open source tool. It was previously it was developed by a single person. Now it joined the Aqua family, and it is has Aqua security support as well. It has, I think, as far as I know, it covers all the vulnerability databases available in the public space. So it can scan any Docker images, even the distro-less Docker images. It can scan and identify what are the vulnerabilities in it. When I compared all the results with against all those, even with the paid tools, Trivi did a better job. So I stopped exploring tools. So if you ask me, Trivi is as of now, is the best way to go to integrate for a container scanning part. Okay.
And it's open source, right?
Yeah, it's completely open source. And even the Trivi, if you want to talk much about Trivi has follows a different way of architecture. Like it will pull all the data sources, and it has created a own master set of data sources, and it is stored in a GitHub. So even if you integrate in your pipeline, right, it will only pull the delta from the Git repo. So the updating the data sources as well, it is very faster, and doing the scan as well, it is very faster. So Trivi requires a own set of session. And just based on my analysis so far, Trivi does a good job in all the spaces. They try to architect it very well.
Does Trivi integrates into the registries, Docker registries?
No. As of now, Trivi doesn't integrate. But if you take Harbor as a tool for your container registry, Trivi can integrate with Harbor.
Oh, okay, yeah.
That's how it can integrate. But Trivi as a scanner, it cannot. It is not directly bundled with the registry, to put it in that way.
Sure.
Yeah. If you ask it is like, can I integrate it with the AWS container registry or Google container registry? We can't integrate. We have to integrate it with the pipeline. But if it is with any open source container registries, very well we can integrate it.
Oh, okay, all right.
I think one thing to check also in these scenarios is if the client already has something or is also willing to go for a paid tool, because there are a lot of functionalities, a lot of plugins available for out of the box integration and all of that, which we should explore maybe. And if those options are also not available, I think it's a good way to go for a tool like Trivi and then try and integrate that.
One additional benefits always we get with paid tools will be a centralized dashboard or a centralized view for their whole application infrastructure. For example, if you're integrating Trivi in your application to do a container scanning, you will get it in the CA and in a terminal, or even you will get a HTML report, but that will be for per application or per service. But if you take Anchor or Aqua related tools, the paid ones, you will get a centralized place where you can log in and you can see all the vulnerabilities of your application in one place. That's the trade-off you will always get it with paid tools or open source tools. Since we are talking about pipeline, I was primarily focusing on not on the centralized tools, primarily focused on which will be very easier to set up in the pipeline perspective. Okay, I'll move on to the next on the container hardening part. Again, Docker files, right? We'll be writing Docker files or to package our application, right? Those Docker files can have a missing configuration. SAST tool is like identifying the missing configuration or identifying the false practices, right? So since it is for Docker file, the set of rules are very less. So this Dockley checks against this set of rules and verifies whether your Docker file is able to adhere to those very basic security requirements. For example, whether it runs as a separate user space, whether it has some health check commands, or whether you are using copy instead of add. All those basic set of static analysis specifically for your Docker file alone, this Dockley tool will do. There are other tools available as well for those. This Hadolin, Claire, and Docker Bench, all those. But Dockley has a quite set of good list of checklists to validate against the Docker files. Okay, and this is about the container. For container, we need to do two things. We need to worry about the whether the packages I use is vulnerable or not, and the other is whether I had a right set of configurations I have defined in my Docker file or not. I'll move to the infrastructure part. In the infrastructure part, we can automate only if we are following infrastructure as a code in our pipelines. We can't automate if we are doing the manual configuration part of it. Like we will be provisioning our own cluster manually and provisioning manually all the services. Then in those cases, we can't use it in pipeline. There are tools available to monitor the runtime part of it. Since my talk is focused on pipeline, I'm not going to touch on those. Like the tools like CloudAware, and Prisma Cloud. Those are the tools which will be giving insight, monitoring your whole cloud infrastructure and identifying any there missing cloud configurations or not. If you see from the infrastructure as a configuration perspective, there are two primary tools. One will be the kubesec. If you are from a Kubernetes world, you can use the kubesec. This kubesec tool will be checking your Kubernetes YAML files and identifying any missing configurations. I think I didn't include. This is the kubesec tool. There are some examples you can refer, or whether you have marked your container to mount it as a read-only file system or not, and run as a non-root. Those kind of settings. This typical settings will usually skip it, right? Basically, for to run a pod in a container, will be just saying the container and the liveness probe, readiness probe, all those things. But we will be ignoring all those security-related flags. This kubesec tool is primarily focused on those. It will identify whether your YAML has missed any security-related configurations or not. And the next one other tool is checkout. This will be for your Terraform files. If you are using infrastructure as a code using Terraform, this checkout tool can scan all your infrastructure code and identify you have missed particular configuration. For example, if you have opened a S3 packet to a public, it can detect all those and raise a concern saying you have a public S3 bucket without any security. These are all the things these kind of tools can check. And there is one more tool called OpenSCAP. This is primarily for a compliance perspective, whether if you are going for any CAS audit or FIPS or stick or any kind of hardening things. If you want to follow any hardening standards, this OpenSCAP tool can automate it for you. It can run against any specified VM and check the list of hardening standards and give a results for you, whether your application followed all those hardening standards or not. This is about the infrastructure hardening part. Okay, we have talked much about the list of stages. Now we will try to put together in some pipeline. This is source code, the typical pipeline. Like we'll be doing a source code checkout and running the test and running some linting tools to do for better code quality. We may run some linting tools, and we will build a built-in package and we'll be running API or end-to-end test and then deploy to some environment. And sign and publish the artifact will be the final stage. So in the tools what from the list we have seen, the additional stages we can add during when we run the linting phases. We can run a secret scanner, we can run those dependency checker, we can run a static code analyzer tool, and we can run an open source license scanner as well, and we can run the software composition analysis tool as well. This particular stage won't give you results. It will just generate you the list of dependencies, and it will upload to your SEA server. I'll show it in a demo how it happens in the background. And in the end-to-end test stage, we can do the artifact scannings as well. Like if you are packaging it as a container, do a container scanning. If you are packaging it in a VM and shipping it as a VM, do a VM related scanning. And even you can do a malware scanning as well. You can use any either open source, Clamavy is the open source antivirus. You can use those antivirus tools to scan your artifact to check whether any malware has been included or not. How your malware could get embedded to your applications, we will be always downloading tons of packages from public repositories, right? There could be any vulnerable malware package in it. So it's always good to have a antivirus scan in your pipeline as well. And also the hardening verification. Hardening verification depends on whether it's a container or Terraform files. You can do the hardening verification. And the one other stage is DAST. I'll cover it at the end. You can deploy your application and run tests against it, like real tests. And the final part is you can sign your artifact and publish it to your any of the registry. If it is a container registry, publish it to your container registry, or if it is a npm package, publish to an packaging registry, either private or public, those registries. So with this understanding, I try to build some sample pipeline. And again, this is particularly my opinionative way of doing it. We'll discuss about what are the ways we can do it. This one of the way of doing it. Like first stage will be installing dependencies, secret scanner. These two will be running in parallel, and then I'll do the building of this application, and then I'll do the static analysis. In the static analysis stage, I will be running the dependency checker. I will be checking the application dependency vulnerabilities, then license checker, and I will be generating, we'll call it as bill of material, software bill of material, SBOM file. There are a lot of standards to it. I don't want to confuse you with those standards. Like with those standards, we can generate what is my application dependency, and I can upload to a software composition analysis server that can take care of further analysis for me. And this Spotbugs, since I developed it for Java, I used the open source Spotbugs plugin to do the static analysis for me, and then I can run my unit test. In the unit test as well, you can write your own security related unit test to verify your authentication and authorization related tests as well. And then you can package your application. Once everything passes, you can package and then do an artifact analysis, like the image hardening, where you can run the dockly to verify whether all the Docker related things are right, or settings are configured rightly or not. And then you can do an image scan to do a vulnerability scan against the OS packages. And then you can do the Kubernetes hardening or the infra. If you follow Terraform files, you can use those hardening. And then you can deploy the application. And after deployment, you can run your E2E tests. Along with it, you can run dynamic tests. I'll cover dynamic tests at the end. Hope it's clear. Before we see a demo, any questions on any stages? Nilo, I didn't check the chat. If there are any questions, I have to answer from the chat. Can you hear me?
No, I think, yeah, if there are any questions, please feel free to unmute yourself and ask.
Maybe just one comment from my experience, and that's probably like a lengthy discussion over, a nighttime conversation. But not all of these scans or results yield a blocking pipeline, right? Like some of those definitely, like you don't want to check in like credentials into your source code, or build your application from there. You really want to block your pipeline at some stage. But for example, when you look at CVEs, they're already live in your code, so there's no real point of not pushing more features potentially, right? But kind of make a wise choice on which ones block your pipeline and which don't.
Yes, Lisa, perfectly. That's why I wanted to cover the strategy part at the end. This I wanted to call it as my opinionated way. and also we can deploy these tools in the pipeline however we like sometimes we may depends on the team as well, right? Whether we need to block the pipeline from, I think it will be mostly the pain point for the developer side. I want to quickly check and verify some features, but all the security tools are blocking my pipeline. If you didn't implement it properly, it will be a pain point. Yeah, I'll cover about it in the next thing. Once we have everyone have the understanding of it, I'll cover about the strategy to approach it. Any questions on the
Got
stage?
a question.
Yeah,
I've
yes.
got a question about license checker. I'm just trying to understand the scenario where it becomes more useful to have it in the bill, because I don't have any experience with it, but I understand that there could be some legal implications. So wouldn't it make more sense to always have that understanding way before we select a dependency library at all? What is the scenario where it is more useful to be in the pipeline for
It can
license
be like
checker?
unit test, right? And you can run it locally also. Like if devs have an ability to run the same unit test in pipeline as well as locally, let's run the license checker also locally if possible.
License
Right.
checking is also a very complex topic, I think, because this, again, is a question of dependencies, right? You might not even know that you're bringing in some, some license down the line somewhere. So that's, I think, the big win when you automate this, so that you're made aware of things that you might slip otherwise.
Right. Okay.
We can debate like license checker while selecting the library itself. I will be more cautious and choosing it, but sometimes people accidentally can miss it, right? And also the transitive part is always the pain. Like we will be referring a library, but it refers a tons of transitive dependencies. So in those cases, the library might not have followed best practices, and they have might be licensed as a MIT license, but they have indirectly used a LGPL package for developing that particular library. So those are all the pain points. These kind of automated tools will help you to resolve it.
And maybe just because we're talking about it, sometimes, not very often still, but it might increase actually, we're signing, along with our contracts, we sign, some regulations or expectations around licenses with our clients. So if you're unsure, reach out to your CP. They should at least be able to find out if there's something that requires us to do this, right? Like otherwise it's, it's a good additional feature, but sometimes it's actually a baseline requirement.
Yeah.
Oh, thank you.
Okay. I'll go to the demo part. I think some questions will get addressed in the demo part. So with this pipeline, right, whatever the pipeline concepts I have talked so far, I tried to build a demo environment. This is completely the demo steps is completely available in the GitHub, so you can follow and develop and try to do in your own environments as well. I tried it using Minikube and Kubernetes environment. I won't dive deep much about how I set up. Basically, this README, I think I will be helping you to, if you want to set up and try, or if you want to showcase to your client to about the practices to improve in the security space. I'll talk about the Jenkins file, how I have written for, I think for few of the tools, I think you need to think about it, right? So first, install dependencies. I think just a Maven command to install the dependencies, like Maven install. I'm just skipping the text and all those static SAS I'm skipping, and the dependency checker and all those I'm skipping it. Just downloading the dependencies alone. The next stage is the secret scanner that we talked about. One special thing with the Trufflewag and Talisman is Trufflewag and Talisman always understands JIT. So whenever if you want to run Trufflewag or Talisman, it will always expect to have a JIT tree structure in your whichever the folder your folder or directory you are trying to run the tool against. For example, if you're trying to run a tool against a particular folder, it should have a .zip directory. That's where I have cloned the repository once again, and I have run the truffle tool. Why this truffle tool looks for a JIT is these tools are primarily focused on scanning the JIT history as well. There could have been secret accidentally pushed, but that our developer or QA or whoever codes it might have found it that they have accidentally committed it, and they might have removed it in the next commit. Without knowing the impact of even the people can learn it from the JIT history and try to attack using that. That's why Truffle and Talisman are most primarily focused on JIT histories as well. That's where the place where we need to clone the repo with complete history again. When Jenkins always do a lightweight checkout, it will don't check out it with the whole history. That's where we need to check out once again and run the truffle tool.
Just to add to that, so Talisman does Git hook integration as well. So that prevents secrets from being checked in from the developer perspective as well.
Sorry, I didn't get the question clearly. Talisman as well scans for JIT diffs.
Yeah, so Talisman uses Git hooks.
Yeah.
So if you do a Git commit, it'll prevent you from committing that change until the secret has been explicitly allowed.
Yeah. Yes, Talisman has both supports for both, right? Preventive and proactive approaches. In the proactive space, it works as a JIT hook. All the developers can install in their local machine, and it will prevent you from making commit itself. But if in case if not everyone will be able to install, or some client team is not willing to install, you can have it in the pipeline to scan for secrets. Talisman can run as a pipeline tool as well. It can scan for JIT history, and it can work as a pipeline as well. I think I'll share a link on how to set it up in the pipeline as well. For this demo, I used Truffle to set it up. I think already some person, I don't remember his name, he written a blog on how to run Talisman in the pipeline as well. Okay. I'll move to next. Next one is on the packaging part. Just since it's a Java application, I'm using Maven package to bundle it as a jar. Next is on the static analysis, the whole set of section. If you notice in this particular section itself, I'm running all the stages in parallel mode. Like these two stages will be running in parallel. Like there will be always a debate. I need to get a quick feedback in the pipelines. My security tools should not impact the original running time of a pipeline. That's what my I had this whole concept in my mind while designing this pipeline. Like whatever I'm going to add in the pipeline, it should not impact the developer's feedback time. That's where I added this secret scanner as a parallel stage to you downloading dependencies. When your application is the pipeline is downloading the dependencies, the secret scanner can identify all your secrets in parallel. You will get an additional benefit of it. So the only additional thing you require is whether you have infra in your CA server to handle multiple parallel processing steps. That's the only thing. And this build runs as an individual stage. This static analysis, again, a set of, again, it's a parallel block. It runs multiple stages. For example, first stage, it runs as a unit test. In Java, we are running it with Maven test or a Gradle test, whichever the tool you are using. And I'm using a dependency check thing. If you notice here, I used catch error block. One of the reasons why I use the catch error block is sometimes you may be spiking out with some new library. We may don't want to fail the entire build. So in those cases, you can fail your particular stage alone. For example, here I'm failing the stage result as failure, build result as success. Only that particular stage, if you see the output in the particular stage, that particular stage will be marked as failure, but the entire pipeline will be green for you. So that you will get the feedback that there is a library you are using having a vulnerability, but it won't stop you from deploying as well. So you can take advantage of those things. It's again debatable. It depends on your application context, like whether how stricter you want to be. Whether if you want to break the pipeline, you can break. Else, if you think, okay, I want to know the feedback, but don't break my pipeline, just let the rest of the things flow. In those cases, you can follow these kind of strategy. Like failing that particular stage alone will be marked as red. The whole pipeline will be like a green. And the artifact the dependency check report artifact, it will be generating HTML report that I'm marking it as an artifact. And next is on the static analyzer. Like I'm using the Spotworks plugin, right? So I'm just running the Spotworks plugin to do it, and marking the Spotworks plugin as an artifact here as well. Okay, and the interesting part is on the license checker. I think people have asked how to integrate the license checker as well, right? In the images. Okay. This pivotal license finder has some few concepts, like you can permit few licenses, like as an organization, for example, your client permits few licenses, you can use it without checking with them. Like for example, as an organization, I'm permitting MIT license. As an organization, I'm permitting Apache license, ESD license, all those. For example, if you permit all those licenses, you can add this a simple YAML structure saying dependency additions, like I'm permitting MIT, whatever the library with MIT license, I'm allowing it to use. Those kind of permitting things you can set. There are also specific things. For example, this particular package, Jakarta annotation API, right? This particular package and this particular version, I check this license and I'm approving it. For example, you might have raised a legal request to review this particular library before integrating it. Once it is approved, you can add it to your dependency decisions, so that you can manage it in your pipeline. Like if any of those violates this dependency decision, the pivotal tool will be raising it like, okay, you are going against your license decisions you have earlier made. Like for example, if you are using a GPL license, I think GPL will not be there in this whole list at all. It will be raising a concern saying, okay, yeah, I found a new package and a new license, so I'm failing the pipeline. And those kind of that is how this license finder works. This is how you can iteratively take the license scanning as a practice, instead of approaching it as a whole. If you add a new library, this license finder can detect and notify you.
Ramki, a quick time check. We have 5 minutes left.
Sure. I'll try to close. Okay. This is what the license finder is, and the next is software composition analysis tool. For this, I'm using a Cyclone DX format. This is an XML format which will have a list of dependencies mentioned. Just you can understand from the table, like a file contains a list of dependencies. This command will be generating a file for me, that is SBOM file, software bill of material. That file I'm uploading to a dependency track tool that I talked about it earlier. I'll show how the dependency track does it after this. This particular stage will never fail for you. You just generate the dependency structure of your application and upload it to your dependency track to maintain it for further. Next is packaging. I'm doing the Docker build command, and then doing an image scan. I'm using the Trivi scan. I'm running it with Trivi and the container imaging. One thing to notice, Trivi uses a cache directory. So always try to mount a shared volume, else it will be, for each pipeline, it will be trying to download the whole vulnerability database. If you mount it to the shared volume to your container, then you will reduce the pipeline running time. And I think for Dockly, there is an official image as well, and you can do just Dockly in the container, you will get the results. And for the Kubernetes audit as well, you can run the kubesec container, and you will get the, if you pass the YAML file as an input to it, and you will get the what are the recommendations to it. And deploy, just since it's a sample pipeline, just did the echo and internal test and did a all test pass. So when it comes to DAST, right, DAST, either you can write your own DAST test, or you can use these kind of tools. If it is a web application, there are OASP Zap, right? OASP Zap tool. I think some of us might have earlier, or else please explore about the OASP Zap tool. That is an open source tool from OASP community to check about vulnerabilities in a web application. This Zap tool has a concept called a baseline scan. Like it can scan for 10 minutes against your any particular URL you are giving, and it will give results against it. Okay, I'll quickly show. Okay, this is a sample pipeline I have run with this particular code. Okay, I'll start with dash scan itself. If you see it will be doing a very basic set of checks. For example, whether a cookie has a HTTP only flag set, whether X-frame options has been proper, all those basic web-related security checks it will be doing, and it will be giving warnings like a cookie is there without a security flag. All those these kind of basic security scans. This is a Zap. They call it as a baseline scan. If you are not able to write your own dash test, baseline scan is the easier way to go. You don't need to write anything on your own. You just need to say deploy your application and give the URL to the Zap, and it will do a scan for 10 minutes and give you a results for you. Even if you're not integrating in the pipeline, at least you can try it in running it periodically in your own local environments to check whether all your web-related best practices whether you have followed or not. This is with respect to Dash. I think for in the Kubernetes hardening space, again this kubesec, right? It will be giving those results for you, like you don't have read-only file system set in your configuration. All those it will be giving it in the command line friendly responses. And image scan, it is again I'm running the trivia, right? The outputs will be in the format of like this particular package. This is the CV and this is the version. If there is any fixed version available, it will be showing them what is the fixed version as well. And you can generate HTML reports out of it as well, but for pipeline CLIs are most friendlier. And this is the image hardening, this particular Docker, right? It will scan my Docker file and it will give what are the missing instructions I have missed in my Docker file for security related activities. And I think again the dependency checker part, again it will scan against your libraries, and it will give you like this particular Tomcat having this CV, and you need to upgrade all those instructions for you. And this license finder, I think as of now, this license finder, it will be saying all dependencies are approved for you. Since I have added the dependency decisions.yaml with the list of dependencies approved. If it identifies any new, it will be printing like this particular dependency is not approved for use from license perspective. And this particular SEA, it generated a SBOM file. It's a XML structure of list of dependencies, and it uploaded to dependency track. Dependency track is a separate application. You can deploy it with your along with your application. What it basically does is once it is uploaded, it can give you an overview. If you see the dashboard, this will be like a whole of your organization or whole of your application, all of your microservices. It will give you a holistic view of the list of applications you are having, and list of vulnerable dependencies you have, all the list of dependencies, and also all the licenses your application is using. For example, if you go inside deeper into projects, I created a sample project where it will be giving a rundown what is the vulnerabilities it identifying. The one good thing for why we need to have a SES, it can do these things in the background. For example, once you generated and uploaded the file, this will keep on monitoring. It will update the database on itself, and it will check whether any new vulnerabilities found. Those vulnerabilities are used. For example, in midnight, there might be a new vulnerability released. That in the next day morning, you will get alerts saying that new vulnerability is detected by this dependency track. It will have a whole set of saying this particular component is out of date. And for example, the same Tomcat one, right? It will be identifying those Tomcat related vulnerabilities, and it will be this has options for email notification, as well as if you can comment the dashboard, and you can know the list of vulnerabilities you have. Since there is only one vulnerability in application, it feels less, But if you add all the applications, you will get the holistic view of what are the vulnerabilities in our applications. This is about dependency set, and it does similar thing for licenses as well. Like what is my application dependency and what is my license and what is that risk. Okay. I think this is about it. And the secret scanner again, just to identify any secrets got accidentally checked into a registry. That if it finds any secret, that it will just simply mark the stage as this particular secret, and it will print a pattern saying this is a secret pattern and this has been identified in this particular line of code. Yeah, this is what I primarily wanted to share. This is a run log of that this particular Java code what I have done. So basically, I written a single endpoint and written a Java Spring Boot application and try to integrate all the tools and pipeline around it. Before I go into questions, so the strategy to integrate it, right? You can strategy will be different from application to application and team to teams. For example, if your team feels we want to have a quicker feedback, we don't want to have any security tools, you can move all these security tools before deploying to QA. You can before deploying to a dev environment, you can have only the application building process, the regular DevOps pipeline. Security related things you can use it, integrate the tools while moving your code from dev to QA environment. And also you can use the catch error on failing the stage related strategies, right? You don't need to fail the entire pipeline. You can fail only that particular stage alone. I think this pipeline is my opinion way of doing it. Whether you can, at which stage you can use, you can take your own decisions by discussing with your own team and have a common understanding. My suggestion would be have all those stages in your pipeline. No, not necessarily to break the pipeline. Have these tools in the pipeline, let it detect and give results for you, and you can take actions before even releasing those applications, kind of things. And some tips would be, we know all this. I think some of the practices, I think most of you might have already know. Just don't procrastinate in adding these tools to pipeline. Just add it to the pipeline. The first question will be like, it will break my pipeline. So we now know an option to have a catch error saying fail only this particular stage, don't fail the pipeline. Use those things for your advantage and start directly adding it to the tools in the pipeline. And try to find your own strategy. Like this particular strategy on having static analysis, running the static analysis during the unit test phase might not work well for you. You can move all these tools after the deploy stage. However, you feel the right for your own set of projects or the team you're working on will be comfortable with. And okay, if you are adapting to even the fail stage, failing the pipeline itself, if any particular stage fails and if you want to quickly deploy, don't try to remove the tool from the pipeline. Just try to use the catch error or skip that particular stage. Even GoCD has options of even if the particular stage is failed, you can skip that stage and deploy it. Try to follow those things, then we'll be able to cover everything. And again, for most of the categories, there are open source tools available. If a client is able to make any additional investment on security, just also you can go with the paid tools. What is the paid advantage you will be getting is the false positives will be lesser. In all the tools we have seen, right, there are possibilities of having false positives. The tools can detect wrongly. So if you go with the paid tools, the maintenance part will be lesser. If you go with the open source tools, there will be a little bit maintenance. We have to do it from our end. That's the primary reason. And just one note I wanted to add is this pipeline is not a complete security strategy for your whole application. It's just one way to detect automated way of identifying all those security issues. Just consider it as a one other way, not a only way for implementing security. That just wanted to add that caution there. Cool. So I think sorry I went 6 minutes overboard.
I think it was really very informative, Ramki.